Hello everyone. How I hope you are doing well. In the previous lecture, we studied the introduce of energy engineering, and today we discuss the solar energy and wind energy system. So our topic name is solar energy systems and wind energy. First we study the solar energy systems. We know that the solar is the main source of all alternative energies on the Earth's surface. Wind energy, bioenergy, ocean energy, and hydrothermal are derived from the sun. However, the term solar energy refers to the energy that is harvested directly from the sun using solar cells, solar concentrators. Solar energy is abundant on the Earth's surface, harvesting it into a useful energy from its challenging and often costly. All of the alternative energy resources, solar energy is the most costly for generation of electricity. Solar energy can be used either as a source of thermal energy when using solar concentrators. Uh, Nowadays, solar energy is mostly used because there are many benefits we discussed next. So first is what is solar energy? Solar energy is the radiant energy emitted by the sun. It is a clean, renewable, and abundant source of energy. Sunlight can be captured and converted into electricity or heat for various applications. The sun, we know that the sun is a giant ball of hot plasma. They release amount of energy in the form of light and heat. Solar energy is a powerful resource that can be harnessed to power our home, businesses, and even entire cities. It's a clean and sustainable traditional energy source. They rely on fossil fuels. How comes energy from the sun? Can anyone give me answer this question? If now, okay, I can answer. We know the sun is about 1.5 million kilometer in diameter, and its entire temperature is about 15 million degree Kelvin. This high temperature combined with a pressure that is 70 billion times higher than atmospheric pressure on the earth creates an ideal condition for fusion reactions. The fusion reaction in the sun involves two hydrogen atoms combining to form a helium atom, releasing the energy in the process. This energy is released in the form of high energy gamma radiation. As gamma rays radiate from the central to the outside of the solar sphere, they react with the solar media and transfer into the lower energy radiation, primarily invisible light and heat portions of the energy spectrum. The sun has been producing energy in this manner for around 5 million years and will continue to do so for several more billion years. The Earth orbits the sun at a distance 150 million kilometers. Solar radiation in the form of electromagnetic radiation travel outward from the sun at the speed of light, taking about 8 minutes to reach Earth. The amount of solar energy reaching a specific location on Earth's surface at a given time called insolation. When the sun is directly overhead and the sky is clear, solar radiation received on the surface is reduced when the sun is not directly overhead due to the more atmospheric medium between the sun and the surface. Some solar energy is absorbed by the atmosphere, reducing the amount of reaches the Earth's surface. Due to this energy comes from the sun. Next is the history of the solar cell. What is the history of solar cell? Throughout the history, humans have used the heat from sunlight to the dry grains, cook food, and heat waters and homes. The concept and the use of solar thermal energy started in 1767 when the Swiss scientist Horace and Saussure invented the world's first solar collector or hot box. Renowned astronomer Sir John Herschel used solar hot boxes to cook found during his exhibition to Southern Africa in the 1830s. Today, solar collectors can gather solar thermal energy in the almost any climate to provide reliable, low-cost source of energy for many applications, including heating water for homes and residential heating systems. Various other industries such as laundries and food processing companies also utilize solar energy. In the recent year, utilities have begun to use solar thermal energy to generate electricity by using steam turbines. The steam is produced by concentrating the solar energy into the water boiler. So next, we divided the solar energy into the different categories. For example, solar thermal energy, solar heating, and we more dividing into solar water heating, solar space heating, solar pool heating, electricity generation using solar concentrators, and photovoltaic cells, solar lighting. Here we discuss solar thermal energy, solar space heating, generation using solar concentrators, photovoltaic cells. First, what is solar thermal energy? Actually, solar thermal technologies involve harvesting energy from the sun for heating water or producing electrical power. Smart scale. Water heating system use plate collector to capture heat from the sun, while solar thermal electric power plant use various concentrating devices to focus sunlight and achieve high temperatures necessary to produce steam for power generation. And solar heat without concentrating can be used for solar heat, water heating, solar space heating in buildings, solar space cooling. What is solar water heating? A solar water heating consists of a solar collector that absorbs solar radiation and generates usable thermal energy. The thermal energy or heat is then transferred to a fluid medium, such as water is a best example. Another heat transfer fluid or air which flows through the collector. The thermal energy can also be stored for nighttime, used for other time when solar radiation is not available. Has a major application of solar water heating system is to provide hot water to individual homes. This is a very important rule for solar energy systems. And next, what is space heating? Solar space heating. A solar space heating system may consist of a passive system and a active system or a mission sword. Passive systems are typically less costly and less complex than active system. However, when retrofitting a building, active system might be the only option for utilization of the solar energy systems. Next is electricity generation using solar concentrators. Concentrated solar power systems use reflective media, such as a mirror, to concentrate the sun heat energy into the boiler to generate steam, which is used to drive a steam turbine and generate electricity. CSP is also used to break down metal oxides to its metal counterparts, such as, for example, zinc oxides to zinc that is used to split water for producing hydrogen. This technology is most useful. For example, there are three kinds of concentrating solar power systems. First is two systems, power tower systems, engine system, and engine systems. And now next topic we discuss also photovoltaic cells because this is very important for a solar panel. Next is how does solar energy work? Actually, solar energy is captured using photovoltaic cells, also known as solar panels. When we map the solar panels, then photovoltaic cell use. Okay, the photovoltaic cell capture the sunlight and further process starting. These panels consist of layers of semiconducting material, typically silicon. When sunlight strikes the solar panel, it excites electrons in the silicon atoms, causing them to flow the generate electricity. So if we saw that photovoltaic cell is a heart of solar energy system. Without the photovoltaic cell, our solar panel cannot work. Okay, this cell converts sunlight into electricity using the photovoltaic effect. When sunlight hits a PV cell, for example, when sunlight strike into the plates of photovoltaic cell, then electricity electric current creates. Now we see that what is photovoltaic cell because we know that photovoltaic cell is a very important role into the energy solar energy system. So very important now what is photovoltaic cell. So we start what is photovoltaic cell. Photovoltaic cell convert the solar energy directed into the electricity. PV based systems are commonly known as a solar cell and are currently used in a number of devices, including calculator, watches, and emergency radios. All of these we use photovoltaic cell. Large scale units can be used to provide power for pumping water, communications, equipment, streets, and lighting homes, each and everything. Mostly we use photovoltaic cells. The PV cell and modules are found to be very reliable in a space application where they are subjected to much harsher condition compared to application. The Hubble Space Telescopes and our communication satellites are powered by photovoltaic technology. The PV system tries to power most of the electronic device in satellites. For example, PV application may be divided into the following categories. For your number one, for example, simple or stand-alone PV systems, PV system battery storage, PV with a backup power generator, PV connected to the local utility scale power projections, hybrid power systems. Each and everything maximum we use PV cells. Uh, Actually, if we see that the photovoltaic cells are semiconducting material to capture the energy of sunlight, which is composed of photons. These photons contain an energy corresponding to their wavelengths in the solar spectrum. When sunlight or photons strike to PV, then electricity generates and we use it for different purposes. Next is components of solar energy systems. Two components are very important for the constructions of solar energy systems. Solar panels, inverter, battery, monitoring systems. They are very important for the construction of the solar energy systems. A basic solar energy system typically consists of solar panels, inverter, and monitoring system. Some system may also be include a battery for energy storage. Okay, the solar panel absorbs sunlight and generate electricity. The inverter converts the DC energy from the panels in the AC electricity, which is a type of electricity used in our homes and businesses. The monitoring systems allows you to track the performance of your solar energy system and see how much energy it is producing. One by one, we see that solar panel this capture sunlight, okay, and then convert into electricity. Second, inverter convert the direct current DC mean electricity from the panels, and then DC current convert into the AC current, and we use has the electricity. Battery store the energy for a long time, for example, 4 hours, 6 hours, 7 hours. Monitoring system track the performance of the solar energy system. And then next is the solar cell material. The materials is a very important for solar systems. The most important part of the construction of the solar energy systems is solar cell material. So we see that what is solar cell materials. The most important part of the solar cell, is the semiconductor layer. We uh, see that semiconductor layers are very important part for solar energy system. There are a number of different materials suited for making this semiconducting layer, and each has benefit and drawbacks. Okay, in addition to the semiconducting materials, solar cell consists of a top metallic grid or other electrical contact to collect electrons from the semiconductor and transformer transfer them to the external world, and a bare contact layer to complete the circuit. This metallic electrical contact must be oxidation resistance to belong the lifetime of the cycle. On the top of the complete cell, typically a glass cover or other type of transparent is placed to seal the cell and keep moisture. Uh, in the solar cell materials, the silicon and gallium arsenide play a very important role. So we see that what is silicon. Silicon is the most popular solar cell material for commercial application because it is available and cheap. Silicon is a cheap, so we use as a material into the solar energy systems. However, to be useful in solar cell, it must be refined to almost 99.9% purity. Silicon can be used in three different forms in PV cell. For example, number one, single crystal, amorphous silicon, and polycrystalline silicon, thin film. Second is gallium arsenide. Um, we use mostly in the solar energy system as a material. So we see that what is gallium arsenide is another material. Purpose it has a semiconducting material for PV cells. It has several advantages. Our silicon-based PV cell. It is exceptionally suitable for use in multi-junction and high-efficiency solar cell for several reasons. Okay, you don't know what is multi-junction. We study in almost next slides. Then next is what is multi-junction cell? Can anyone know what is multi-junction cell? If no, then can answer. Can give me answer. Okay, I answer this question. Multi-junction cell. We know that most common PV devices use a single junction, okay, or interface to create an electric field. In a single junction PV cell, only photons whose energy is equal to or greater than the band gap of the cell material can flee an electron for an electric cell. This is reduce the efficiency of a single junction cell. One way to address this issue is to use two different cells with more than one band gap and more than one junction to generate a voltage. These junction, these junction devices, these are referred to as multi-junction cell. Multi-junction devices can achieve higher total conversion because they can convert more of the energy spectrum of light to electricity. Multi-junction device is a stock of individual single junction cell in descending order of band gap, and the top cell captures the high energy photons and passes the reset of photons on the next layer of the lower band gap. So mostly we use in the solar panels multi-junction cell. We also discuss solar lighting. Most commercial buildings are designed to use electric bulbs to provide interior lighting. Currently, attempts to underway to use sunlight directly for interior light lens collectors, reflective light pipes, and fiber optic bundles. Hybrid solar lighting is one such technology. It collects sunlight and routes it through optical fiber into building where it is combined with electric light in a hybrid light sensor keep the room at a steady lighting level by adjusting electric light based on sunlight available. Okay. This new generation of solar lighting combine both electric and solar power has a reduced cost. Uh, this is a solar lighting. Okay. Now is what is advantages of solar energy. We also know there's there more advantages of solar energy systems. Number one, clean and renewable. Mean solar energy does not produce harmful emission like fossil fuels because no any emission emit into the environment and not any pollution created, no damage our environment, forest, river, etc. Reduce reliance on fossil fuels, help to decrease our dependence on non-renewable resources. With the help of solar energy system, lower electricity bills. Mostly we install the solar energy system because we want to reduce the solar electricity bill. This is a very big problem for each country, each house, each city. Okay, so I think the number one advantage is lower electricity bill, clean and renewable. Then increase property values. Mean homes with solar panel often have a high value. Government incentives. Many governments offers financial incentive for installing solar panels. There reduce our electricity bill. Study have shown at home with solar panel are often sell for a high price than without them. Is of solar energy systems. Uh, if advantages is due to the solar energy system, then disadvantages is also. So first is high upfront cost. Solar panel cost is very high. So this is a very drawback. So while the cost of solar panel has decreased significantly, the initial investment for a solar energy system can still be substantial. This can be barrier for some homeowners and businesses. And second disadvantage is weather dependent. We know that the solar panels depend upon the weather. if our weather is cloudy, then uh, they can the panels solar panel cannot get sunlight, and this is the most disadvantage for solar energy systems. Okay. Second, third is limiting energy storage. While battery storage technology is improving, storing excess solar energy for nighttime or extended cloudy periods can be expensive. System without battery storage may not be suitable, but for our application. Space contracts. This is a disadvantage of solar energy systems. For example, installing a sufficient number of solar panels to meet your energy needs may require a significant amount of rooftop space. This can be limitation for homes or businesses with limited roof area. And environmental impact of manufacturing mean the manufacturing process for a solar panel can involve the use of hazardous materials and generate some pollution. Okay, when we during the preparation of solar energy systems, some pollution created. However, this impact is generally much less significant than the ongoing pollution from fossil fuel power plants. So this is a uh, most really faces disadvantages for the construction of solar energy system. Last is land use for large scale of solar farm. We also know that when we install the solar energy system, then the solar plates occur a uh, maximum place. So this is a big. This is a we cannot say that it is a big problem, but this is a problem. So while large-scale solar farm can generate significant amount of electricity, they require substantial land area. This can raise concern about land use competition, particularly in densely populated areas. So this is the disadvantages of solar energy system. And next is application of solar energy. Many applications solar energy. So we see that essential power homes and provides water, commercial, industrial, off-grid application, transportations. We use solar energy system. Solar, we know that solar energy can be used in various applications. It is commonly used in homes to provide electricity and hot water, businesses and institutions, and increasing turning to solar power to reduce their energy cost. Solar energy is also used in industrial process and to power homes and facilities to remote location. They are not connected to the grid. Solar energy is playing a growing role in the transportation sector, powering electric. So many uses of solar energy system. So this is the solar energy systems. We discuss what is solar energy, what is categories, and what is advantages, disadvantages, benefits, working process, photovoltaic cells. Actually, this is a main parts for understanding the solar energy system. So, solar energy system topic is closed. Next, we discuss what is wind power. Okay. So,
Uh, Sorry, ma'am. There is one question just for information. What kind of material or components we are using in solar panel?
mostly we use silicon, okay, and arsenides, germanium arsenides, like, but mostly we use for the preparation of solar panels, almost silicon mostly use.
Okay, thank you.
Depend upon what type of we want to construction of the solar panel. Then we use according to the material.
Okay,
Okay.
thank you. Thank you.
Anyone question more? Okay, so we will meet again after a 10-minute break. So next we'll topic start.
Okay, thank you. जी जवेद साहब, ब्रेक हो गई है 10 मिनट की, शायद 10 मिनट बाद फिर क्लास स्टार्ट होगी।
Okay, okay, thank you.
Okay, now after the break, we start next topic. Topic is wind energy system. Before the wind energy system, we discussed solar energy system. Now we discuss wind energy. Okay, first, what is wind energy? What is wind energy? The kinetic energy of wind is harvested using wind turbines to generate electricity. Among various renewable energy sources, for example, wind energy is the second most technological advanced renewable energy source. Hydropower is the first. Okay, hydropower is the first technology, and second is the wind energy. Wind energy convert potential energy to potential for converting wind energy to electricity. A number of issues must be addressed before it can be used to to its full potential. Wind in every corner of the earth. We know that our earth, every corner wind is present. However, it does not blow constantly. Okay, every place our wind is not remain constant. Wind is change. Okay, one place wind is different and then other is different. In addition, it must maintain a certain speeds to be effective for running a wind turbine and generating electricity. So this is we also study then what is the history of wind energy. The utilization of a wind energy can be dated back to as early as 5000 BC when wind energy propelled boats were sailing along the Nile River. By 200 BC, the use of windmill in China for pumping water was documented. Vertical axis windmills with worn reef sail were used for grading grain in Persia and the Middle East. During that time period, the primary applications were for grain grading and the water pumping. Between 1850 and 97, over 6 million mostly small 1 horsepower or less windmill were installed in US alone for conversion for of the wind energy to the mechanical energy. Okay, the first installation of windmill in USA convert wind energy into the mechanical energy. The primary use was water pumping for stock watering and meeting the water needs to for farms and homes. Very large windmill with rooters up to 80 meter in diameter. Okay, almost the diameter of windmill 18 meter were used to pump water for steam, railroad, train. They provided the primary source of commercial transportation in areas where there were no navigable rivers. Uh, a new market for wind energy generated electricity wind farm began in early 1980 in the USA. The Public Utility Regulatory Policy Acts of 1978 promoted wind farms. This required utilities by electricity from private non-utility individual and developer that are using renewable energy resources for electricity generation. California, USA lead the use of wind energy uh, uh, wind mill, which was nicknamed as the Great California Wind Rush. When thousands of windmills were driven to the wind program in California in the early 18s. By 1997, almost nearly 2% of California electricity was generated by wind. Has the cost of the technology continued to be declined, other area in the USA, namely Great Plain, specified Northwest and Northeast, began development of wind farms. Modern wind turbines using advanced technology are able to produce electricity. Cost for home businesses and even utilized in the last 19th century. The multi-blade windmill design was introduced to generate electricity. Wind power continues to prosper. A new turbine design are helping to reduce cost of wind power and make wind turbine economically reliable is more precise in the world. So Europe is reading the world utilization of wind energy. The European Wind Energy Association is a project where wind generating electricity capacity seven almost in 210. The USA is almost making a major push towards the use of more wind energy. So this is a history of wind energy. Okay, the next is how does wind turbine work? Can anyone answer this question? If not, okay, no problem. We know that wind pushes the turbine blades, pushing them to rotate. The rotation of the blades, okay, when wind strike the blades of the blades. Then rotation created shaft connected to the gearbox. The gearbox increases the rotational speed of the shaft. When winds strike with very high speed, then the rotation of shaft is high. If the speed of wind is low, then the also rotation of shaft is low speed. The high speed shaft then generate with produce electricity. Okay, so this is a working process of wind turbine. Next is types of wind turbine. Two types of wind turbine we use: horizontal axis wind turbines, vertical axis wind turbines. Mostly nowadays uses horizontal axis wind turbines. Vertical axis wind turbine use, but not more use. Mostly horizontal axis wind turbine use. So next we discussed what is horizontal axis wind turbines. Okay, so horizontal axis wind turbines. The blades of the horizontal axis wind turbines spin in a vertical plane during rotation. Blades move rapidly over one side, creating a low pressure area behind the blades and a high pressure area in the front of it. The difference between these two pressures, okay, due to the wind, the difference created between two pressures, a force which causes blades to spin. The horizontal axis with wind turbine have a main rotor shaft electrical generator at the top of the tower and are pointed into the wind. Small turbines are pointed by a simple wind vane, while large turbine generating use a wind sensor coupled with a servo motor. Most have a gearbox which turn to slow rotation of the blades into the quicker rotations and then more suitable for generation of electricity. So this is a horizontal axis wind turbine with the help of horizontal axis wind turbines we generate electricity. We see different types of horizontal axis wind turbines, different types horizontal wind turbine we use and generate electricity. Next is advantages of horizontal wind turbine. The design and location of the blades provide a better stability of the structure. The ability to pitch the rotor blades in a storm minimize the damage. The use of a tall tower allows access to longer drill inside with wind shear and placement and uneven length. The manufacturing cost can be less because of higher production volume. Okay, due to the high production volume, the manufacturing cost is less. Larger sites, because we know that wind power system size is very large. Uh, in general, higher capacity factor and efficiency is high and capacity is also high. Next, disadvantages of horizontal. Tall towers, long blades are difficult to transport. We know that the size uh, of the fin blades very high. Okay, so in transportation of this very difficult uh, due to the large size. Because the size is almost 180 feet long. So you can imagine that how much long. Next, high install cost, high maintenance cost. Horizontal axis wind turbines are mostly widely used for commercial power generation. Currently, three-blade rotor system prefer, however, in the past, both one-blade, two-blade wind turbine have been designed and tested. Uh, Before the years, mostly one blade, two blades, and three blades wind turbine also used for generate the electricity. Next, very important for the designing of wind turbine. Wind turbine components, you see the diagrams are components show that, for example, first is Nestle, rotor blades, hoop, low speed shaft, and gearbox, high-speed shaft with its mechanical brake, electrical generator, yaw mechanisms, electronic controller, tower, any anemometer, wind fan. This is a very important components for the construction of the wind turbine. If you don't know these components, then you cannot understand the working process, construction, of the wind turbine. So one by one, we discuss in detail because it's a very important. Nestle, first is Nestle. The key of components of a wind turbine. Okay, this is a key components of wind turbine, including the gearbox and the electrical generator. Next is rotor blades. The rotor blades capture the wind and transfer its power to the rotor hoop. Okay, a 1000 kilowatt electric wind turbine has rotor blades that are about 27 meter mean 80 feet in length. The blades or rotor catch the wind. Okay, the blades catch the wind and cause the movement of the blades. So rotor blades are very important because this capture the wind and movement of the blades. This turns the shaft due to the blades shaft turn the generate then turn in this movement into electricity. Blades come in many sizes. Okay, for example, 62-meter long or rotor diameter is 1 to 4 meter. Next is hoop. Hoop of the motor is attached to the low speed shaft of the wind turbine. Okay, we attach hoop for low speed shaft of the wind turbine. What is low speed shaft? The low speed shaft of a wind turbine connect the rotor hook to the gearbox. The rotor rotates at about 1930 rotation per minute. Okay, per minute rotation is 19 or 10, 13. 1000 kilowatt wind turbine. The shaft contain pipe for the hydraulic system to enable and the aerodynamic brakes to operate. Next is gearbox. Gear connect the low speed shaft to the high speed shaft and increase the rotational speed from about to 19 to 13 rotation per minute, about 1018 rm, which is required by most generators to produce electricity. The recent design uses a direct drive. Okay, generators they operate at lower rotational speed and do not need gearbox. Into the direct drive, we cannot use gearbox. Next, what is high speed shaft and how it work? This drive the generator and employs a disc brake, which can be applied mechanically, electrically, or hydraulically to stop the router in emergencies. So high speed shaft use stop router in emergency case. Next is electrical generator. Electrical generator convert the mechanical energy of the rotating shaft into the electrical energy. So electrical generator work convert mechanical energy into the electrical energy. Okay. Next is yaw mechanisms. The turbines must face upwind for the power production. The yaw drive is used to keep the rotor facing into the wind as the wind direction changes. Downwind turbine don't require a yaw drive since the wind blow the rotor downwind. Next is electronic control. Electronic controllers play a very important role in the wind turbine components. The controller start the machine at a specified wind speed, which is generally between 8 and 16 mile per hour almost, and shuts off the machine at about 24 meter per second. The pines do not operate at wind speed above about to 4.6 meter per second because they might get damaged above these wind speeds. So our most wind speed is 24.6 meter per second. When we apply high speed, then our blades are damaged. Tower. Tower is a high stationary spore structure of for the wind turbine. So this consist wind speed can be sustained for the operation of the wind turbine. Next is anemometer. It's measure the wind speeds. We use this for measuring the wind speeds. What is wind speeds? Because now we study when increase the speeds above 24.6 meter per second, then our structure is damaged. So this is a measuring device and tell us the speed of the wind. Wind van. It measures wind direction. Okay, it tells us what is the direction of wind and directs the yaw drive the appropriate orientation so that the turbine is probably aligned with respect to the wind direction. This is all the components of wind turbines, and this is very important for construction. Next is vertical axis wind turbine. Before we discuss horizontal axis wind turbine, now vertical axis wind turbine. Okay. The blades of vertical axis wind turbine spin in the horizontal plane. Vertical axis wind turbine have the main rotor shaft running vertically. Okay, two types of vertical axis wind turbines is radius wind turbines, Savonians wind turbines. You see in the diagrams, radius wind turbines, Savonius wind turbines. So we discuss one by one. What is radius wind turbine? The most common type of vertical axis wind turbines is the radius wind turbine. The design of this type of turbine, you a diagram. Okay, you see. Generate an external power source is required to start the rotation. The starting torque is very low. In the newer design, three more blades are used, which results in a high for the rotor. Solely is measured by blade area over the rotor area. New Darius type turbines are not held up by K wires but have an external structure connected to the top bearing. So this is a Darius wind turbine. Next is Savonius wind turbine. The Savonius wind turbines of two half cylinder mounted on a vertical shaft that has S-shape appearance when viewed from the top. You see the diagram of Savonius. This jet type vertical axis wind turbine turns relatively slowly, but it's a high torque because of the scopes experience less drag when moving against the wind. The differential drag cases of Savonius turbine to spin. Most of the swim area of the Savonius turbine is near the ground, therefore the over energy extraction efficiency is low. This efficiency is lower than radius wind turbine. Next is the advantages of the vertical axis wind turbine. The turbine are easy to maintain because most of their moving parts are located near to the ground. Due to the present mostly parts present near to the ground, so the we can maintain easily. Next, router blades are vertical. Okay, the blades are vertical, not horizontal. Therefore, a yard drive device is not needed. So, the important thing for our knowledge into the vertical wind turbines yard device not use. Okay, the vertical wind turbine have a higher air fuel pitch angle, giving improved aerodynamics while decreasing drag at low and high pressure. The turbines are better suitable for masses, hilltops, and passes as this location can have higher wind speed near the ground. In these places, vertical axis wind turbine placed close to the ground. Okay, we vertical axis wind turbine near to the ground can produce more power than the horizontal axis wind turbine plays higher up. So the important thing for our knowledge, vertical axis wind turbine produce more power than the horizontal axis wind turbine because the reason is vertical axis wind turbine near to the ground. This is the reason for a generation of high power. Turbine does not need a freestanding tower in the designing of vertical turbine axis. We cannot use a freestanding tower. The turbines have very high starting torque. Okay, so torque is very high. Therefore, these are better for water pumping. So these are the advantages. Also, the height and swamp area may be limited. This area also limited, not more. Generally, a flat surface is necessary for their installation. Otherwise, the installation cost will be high. Okay. Installation area, surface area very important. Otherwise, cost is very high. Strong structure is necessary to keep it straight, increasing the cost. Most vertical axis wind turbine produce energy at only 50% of the efficiency of horizontal axis wind turbine. So this is advantages and disadvantages of vertical axis wind turbines. Okay, next is wind farm location. Uh, Wind farm location is a very important for the installation of wind turbines. Wind farm mean where place the place where we install the wind power systems. So a wind farm is a location of a wind turbine in the same location and it is used for generation of large amount of electricity. Even if all the individual wind turbine are pretty same, the power production generally varies from one turbine to another turbine. The operation and the power management is rather complex and load management is necessary before feeding to the grid. Due to the variable of the power production and the equality of the power, the integration of the wind farm to the power grid is complicated. A number of studies have addressed this issue, and different techniques and methods for grid integrations have suggested. So here we uh, two form of wind farm, two location of wind farm. Number one on shore wind farms, and the second is offshore wind farms. Uh, Onshore mean will install at the surface of earth, and offshore we install at the river. So offshore is a very important for wind farm location. Offshore wind are generally located about 10 kilometer or more from the land. Offshore wind turbines are less than turbine on land. The wind resources in the water are much more consistent compared to land. So, just like onshore wind farms, a number of wind turbines are lined up in the array to build our offshore wind turbines, such as arrangement. One significant difference between the offshore and onshore wind farm is that only horizontal axis wind turbines are used in offshore farms since they are easy to install and also they provide highest capacity. The installation of the wind turbine offshore involves several steps forming identification of the location for offshore wind farms. The turbines are various types of ensuring methods have been suggested and discussed later. Okay, otherwise our lecture more long time. Okay, so this is a very important thing for the constructions of the wind power system. Here we also discuss low frequency noise for wind turbines. I think so. The major issue created due to the wind turbine is the noise. One of the major concerns with the wind turbine is to low frequency noise that is generating by rotating turbine. Because of the low rotational rates of the turbine blades, their peak energy rated by large wind turbines is in the infrasonic range with a peak of 8 to 12 hertz range. For smaller machines, this peak can extend into the low frequency because of high rotational speed and multiple plates. The level of the infrasound radiated by the largest wind turbines are very low in the comparison to other sources in these frequency range, such as sonic bombs, shock waves, and explosion. The dangers of hearing damage from wind turbines, low frequency emission in the remote to non-existence, however, is often connecting with the periodic nature of the emitting sounds rather than the frequency of the acoustic energy. The noise from wind turbines is most cases lower than that from their noise sources such as roads, airports, and construction machinery. In urban areas, the noise is masked from other activities. However, in rural environment, where the background noise typically is low, okay, the noise can be annoying. Also, in urban areas, the noise can be annoying in the night time. In rural areas, wind turbines may be only major source of noise. Various engineering techniques such as insulation of nestle can be used to reduce the noise level. So we try to reduce the noise level who created with wind systems. So the aerodynamics noise, which is depend on the tip speeds, can be controlled by lowering the tip speed to maximum of about 60 meter per second. However, in the recent year, the size and also the tip speed of wind turbine were increases. The current generation of wind turbine is operating at tip speeds up to 80 meter per second, indicating this noise again may be problem with respect to public acceptance. So this is the problem of noise. Here you see the offshore wind farms. So our lecture is ending. Our last topic is wind turbine. We cover today. We cover the solar energy systems and wind turbine energy system. First, we study the what is solar energy. Into the solar energy, we study what is solar advantages, disadvantages, applications, what is photovoltaic cells, how can work. Next, we study wind energy. So first, we study what is wind energy, history of the wind energy, and we also study what types of um, wind turbine. We study two types, horizontal and vertical. Then we also see what is advantages and disadvantages of horizontals and what is advantages and disadvantages of vertical. And we also study waveforms and onshore, offshore.